All right, this is Mr. Eggleston. This is the second time I've done this video because the microphone was turned off. So here we go. This is lesson 5.3 for Algebra 1, functions in multiple representations. All right, you're going to learn to evaluate functions represented as a graph, a table, or equation. Now, the equation we've done. We actually done graphs too, I suspect. But I know for a fact we've done equations because we were looking at that last time. Basically, the equation would be if f of x equals 3x squared plus 1, and they say now evaluate g of x at 2, or if we write g evaluate at 2, that's what this is, g of 2, all you got to do is wherever you see x in the equation, and there's only one instance here, it's x squared, you replace that x with the number 2. So now that x is now 2, and so you have to evaluate this. Well, it's a little bit complicated. 2 squared is 4, so you evaluate this. Remember orders of opposites, so we got 4 times 3 plus 1. Well, 4 times 3 is 12 plus 1, and so it's 13. So we can literally say g of 2, if I can, there we go, equals 13. And that's how you evaluate from an equation. Pretty easy. Now we get to look at, and I'm sorry about all the writing, but I was a little mad at myself for not checking the microphone to be turned on when I first did it. So I'm just going to keep it and we'll talk. All right, today we will be looking at 3 different functions, f, g, and h. Values of f are given in the table, so I labeled it f of x. The complete graph of g is shown, so this is g of x, is the graph, okay? And then h of x is given to you as an equation, so that's h of x. And I just wrote it here because you have to read it because you might have missed it. All right? So I'm just going to check something real quick. Oop. I want to make sure that I just screwed it up. Oh, well, I'm just going to go with it. I'm pretty sure I am recording my voice. So find f of 5, g of 5, and h of 5. Well, f of 5, since f is since f is the table, you just hope and pray that 5 is shown on the table. Here's the input. I wrote input. This is the output. So here's 5. So f of 5 is equal to -2. That's where I got that from, just by looking at the table. G evaluated at 5. Since g is the graph, you have to look along the x-axis for 5, which is all the way over here on the edge. And then we see what the value is. And you see it's 1. So g evaluated at 5 equals 1 from the graph. And then h of 5 means we plug in 5 for x into this expression. So h of 5 equals x squared is now 5 squared minus 5. 5 squared is 25. 25 minus 5 is 20. So we could say h evaluated at 5 is equal to 20. All right? It's pretty easy. Part 2, or question 2a, is what values of x does the function g, looking at the graph, this thing, use? Well, you have to just look and see when g begins, the graph begins along the x-axis. So we see it begins right here at -4. And then we keep going, blah, 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 and we see it ends right here at 5. So we would say that, I'm sorry, there we go. We would say x is between -4 and 5. This is a compound inequality that we saw when we were talking about inequalities. All right, remember this is basically saying just the way it looks, that the number x is between -4 and 5. It's in between them. And because it's or equal to's on these, the lines underneath, it includes -4. So x is between -4 and 5, including -4 and 5. You include the endpoints. And we know that because, remember, way back when, if we saw that the circle was closed like this one is, it's or equal to, it includes that point. If it was an open circle like that, with the line going up, it would not include the point, and we would have to use a different notation. Because the graph begins at -4 and ends at 5. All right, what values of y does the function g use? How do you know? Well, very similarly, we kind of look along the y-axis, and we see the graph begins here at -2, and the highest point on the graph is up here at 4. So the range is between -2 and 4. All right, notice we used y, because y is the output. All right, we don't use x, but we could also use g of x too. So we write it in compound inequality. -2 is less than or equal to y, which is less than or equal to 4. Or you could say y is greater than or equal to -2 and, because it's an and, less than or equal to 4. We could also use function notation. So since we're talking g of x, that's the range. Oh, that's the output. Notice when we look for the values of x, we were looking for the domain, because remember, domain is the input. So that's looking for the domain. And when we're looking for the output, that's the range. Gotta get used to the language. It's used throughout math. Okay? One of your classmates makes a claim that the outputs of h will only include positive values, since squaring any number always gives a positive. All right, that may be true, but he's forgetting that we're also subtracting 5. So if you only consider numbers like 3, 4, 5, or -3, -4, -5, you would say yes. But you have to include all the numbers. So if x is at -1, you get a -4. So the answer actually is no, you can have negative numbers. All right, that's the answer to this. All right, which function f, g, or h has the greatest y-intercept? How do you know? Well, you just evaluate it, and I did that. Okay, the last thing, if f of a equals -2, find f evaluated at a minus 1. So this is a little bit weird. So they're saying the output, that's what this means, the output of f equals -2. And so you have to go back to the table, and you better hope that there's an output that's -2, and there is right here. When x is 5, when a is 5, you get an output of -2. So we know f of 5 equals -2. Now they're asking you evaluate what f of a minus 1 is. So you literally go f of 5 minus 1, because you subtract 1 from a, and a was 5. So they're really asking, what is f evaluated at 4? So we go back to the table, and yes, and lo and behold, we have the value of f at 4 is 3, I think. I'm being distracted by my noisy students coming in. And there you go, finally. Lesson 5.3, functions and multiple representation. Quick notes. Functions can be evaluated from a table, a graph, or an equation. Given an input, find the corresponding output. In an equation, all that means is substitute the x value in and evaluate. If you're looking at a graph, it just means looking at the value of the output when the x value on the graph. And there you go. I hope that was very boring.